Good morning, welcome back. Let's get you some examples. So we're doing stoichiometry, which in some ways is super similar to all your conversions, all your unit canceling deal. Stoichiometry. So things that are similar to the things that you already know. It's all about converting those units into other types of units. Got that same do-do pattern that you're looking at, that is your starting thing every time is that pattern. Once you've got your units set up all the way across, units and compounds now, because now we're reacting something, so like the compound you start with and the compound you end with also matter, because there's this mole ratio step in the middle. Yeah, right. So we got your template in the previous video. Your template looks somewhat like this. You can write that in like fluorescent neon colors somewhere in your note and use it forever and ever and ever. That pattern, anytime you're going from grams of something into grams of something else and there's a reaction in the middle, anytime that's happening, you can use that template. That's all your units and all your compounds the whole way through. The things that will change are the masses of your compounds. So depending on what it is that you're looking at, those masses will change. And your reaction step. So whatever the reaction is, you'll use the mole ratio from that reaction in your mole ratio step, the one where you're comparing moles to moles. Aside from that, the rest of that, I mean, obviously you're plugging in like what your compounds are, but that template is good to go through the rest of time. So let's do an example. I'm thinking we're going to do this as your first example, so just on the bottom of that mole ratio page from Friday. Off we go. So suppose that 4 grams of H2 were used. The question is, how many grams of water would be produced? Here we go. Find your number. There's your number. So we've got 4 grams of H2. All of those things are important. The number is important, the unit is important, and the compound is important, because we'll use all of them along the way. That's our number, that's our starting thing over 1. All right, and what are we solving for? Suppose 4 grams of H2 were used. How many grams, so we're solving for grams, of water would be produced? Okay, so we're going to solve for grams of water. All right. And from here, you have a ton of options. You can take that template and plug into the template. You can think this through again, and I'll tell you for now, this is 4 steps. A lot of this you can kind of deduce from your disco pattern. You're starting with grams of H2. We're going to get rid of it. So down here is grams of H2. And you're solving for grams of water. So on that last fraction, you're going to end up with grams of water. And that middle step, sometimes they always moles in the middle. So in your middle step, you're going to have a mole ratio, moles in the middle, because that's your reaction step. That is the step where one thing turns into the other thing. We're going to be canceling out H2. You're starting with H2. That's your starting thing. You're solving for H2O. You want H2O to wind up on top. So we're going to put the moles of the thing that you want on top, the moles of the thing you're getting rid of on the bottom. That's your mole ratio step. fill in some more of this pattern, you gotta get your grams of H2 into moles of H2. And for your final adventure, you've got moles of H2O that you're going to convert to grams of H2O. That one's so bad. It does look, a little bizarre the first few times. So it's grams of your starting thing converting to moles of your starting thing. So your starting compound is still H2. And the moles of your starting thing are going to react to form, or, here's your reaction step. You're comparing two things that are both in your reaction. So we're starting with H2, we're going to solve for H2O. Again, it does not matter if these are reactants or products. You don't care. You're starting with whatever one you have a number for, you're ending with whatever one it says how many or how much. And that's all. Many reactions are reversible, so like forward and backward are kind of arbitrary anyways. Some are not, many are. So whatever compound you started with is on the bottom. You want to get rid of that. The thing that you're solving for is going to be on the top. You want to solve for that. Your moles are how you take it through the reaction. So we're going to solve for the ending thing. And since usually we want to put this on a scale, we'll take it through its molar mass again to the moles of the ending thing. That's your units and your compounds. For the next step, we look at each one individually. Here we've got a molar mass. Grams to moles of the same thing. You're going to put a molar mass right there. Molar masses are all on your periodic table. Find the element that you're looking for. Pull the molar mass from the periodic table. Here you've got H2. So take that mass of hydrogen times 2. It's that many grams in 1 mole. Here's your other molar mass. Here's your other grams to mole situation. And this is your other molar mass. Here you're looking at water, H2O. Take those H2 plus the mass of the oxygen. That's your molar mass of water. It's that many grams in 1 mole of water. I didn't write that out. What I just did was 2.02 plus 16.00, 18.02. This middle step is your mole ratio step, your step that's this kind of stuff. So your mole ratio step, here, we're still like on this page, even though we're like on a different page. Here's the reaction that you're looking at, and you are finding the mole ratio of H2 relative to H2O. In this case, we've got coefficients of 2 and 2. Mathematically, you could reduce that. A lot of you really wanted to, mathematically reduce, which is fine. The math is the same. I typically keep them the actual coefficients, just so that when I'm kind of checking backwards, because I know that math is the same and whatever, but when I'm checking backwards, I can see exactly where I pulled my coefficients from. But it's a matter of preference, really. And there you've got it. You've got your whole deal. And I'm just gonna do this one. You can do this in your head. You're right. Those two equal 1. Anything over itself is 1. Got 4 divided by 2 is 2. 2 times 18.02 is 36.04. Or you could calculator that. And I only have 1 sig. No, I have. Oh gosh, I'm not doing anything. 3 sig figs. I've got 4.00. Okay, so if we're doing this exactly, we would keep 3 sig figs. There you go. Cool. So that's your first example of stoichiometry here. I wish I could pitch it to the class and ask if you feel ready to do the next few on your own. Your next step will occur on, let's see here, this page. So you're going to be going here next. And really, this is another thing where there's a total pattern. How many grams, equal sign grams. Sodium sulfate, here you have to translate what it is. Sodium sulfate. This is sodium hydroxide. Hydrogen sulfate, that's sulfuric acid. You don't know that, that's fine. But there's no sodium in this one, it's not that. That's water. Sodium sulfate. Okay, so how many, equal sign, grams, sodium sulfate, just translated those words, will be formed if you start with, okay, cool, and there's your number. This could say, that part actually doesn't matter. Your number is what tells you that's the starting spot. 200 grams of sodium hydroxide. There's your sodium hydroxide. And you have an excess of sulfuric acid. I'm glad I'm doing this because this will sometimes, you know what this means. So excess means too much. So what they're saying in this part right here, that excess of sulfuric acid means that we have too much, we have an excess. What that translates to, don't worry about it. You have too much, you have more than you need, it's not gonna run out, you're not gonna have any like issues with that. Excess kind of means you can ignore that because it's not gonna factor into your math. You have too much of it, it won't limit you. The only thing here that will limit you is this limited amount of sodium hydroxide. So that is what will determine this whole math equation thing. You have a number of sodium hydroxide, like an actual amount, and an excess of sulfuric acid. Other things that you might have an excess of, for example, if you're burning something in the open atmosphere, like a bonfire in the backyard or something like that, the thing that runs out is the thing that you actually have to kind of worry about. Whereas like your bonfire in the backyard, you probably have an excess of air sitting around. You're not going to run out of air if you're burning this in an open area. This is also why you do not burn things in closed areas ever, 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 because you can run out of air. For example, if you're in a closed environment, that is an actually serious issue. But if you're in an open environment, then you have an excess. If you have an excess, you don't have to worry about it. You have enough, basically. So this excess word means you have enough. That was probably a better translation. You have enough of that thing. You don't have to worry about it. The only thing that you're actually kind of concerned with and mathing with here is this thing that they give you a number for. Coming soon, they'll give you a number for each of these things, because excess doesn't necessarily happen all that often in the real world. The air being an example of excess if you're in open air. Yeah. Anyways, but for here, you just have one thing that's limiting you. You're going grams of one thing to grams of something else. That's a 4-step. I'll set up your template here and then let you do the rest of the math. You're gonna take what you start with, cancel it out to the bottom, take what you want, that is what you want left on top. You're changing compound, there's a reaction here. There's this mole to mole step in the middle. Cancel out the thing you're getting rid of, solve for the thing that you want. And then go ahead and fill in. take it backwards. You're solving for moles of the starting thing so that you can put it through this reaction step. Here you've got moles of the ending thing. And in this step, you're just turning that into grams so you can put it back on the scale. Alright. So I will give you this. And for tonight, you're going to solve 1 and 2 on this page here. So just 1 and 2. I'm not giving you this template, but use the other templates that you have to build it. And yeah, enjoy. See you soon.